attendees to hear you. This system will notify you once you begin your broadcast. The broadcast is now starting. All attendees are in listen-only mode.
Oh, okay, we'll start with the data extraction with our historical data analysis. Okay, so we'll see some of the table first and extract the complete data from there. I need first few script and MySQL. Root. Let me see if table is there already. And from this table, we'll pick up this database and so tables. Dim customer is my table name where record is there. So select star from dim customer. Total number of row we have 6 to 12. Okay, let me create the flow first. So here we will extract data from downstream source. Now flow wise upstream source is there. And this is connected with a downstream source, which is our RDBMS. So this is some web server you can call, and this is your RDBMS. Now this data we need in HDFS. RDBMS is installed in my guest host server. This is with some other IP. This is in operating system, and this is in other operating system. HDFS is running in Cloudera, and Cloudera is deployed with the CentOS. If I write the version, this is 6.4, and this is 10.14. So we'll extract all the data from this to this, and we said some ETL will be there for data extraction. Now that ETL we are using as a scoop. So first extract, stepwise will write. First extract all data from RDBMS to HDFS. Okay, so we need this complete data in our HDFS. One by one query, we know already what query we are running, but we will use now a script, because if we want to extract multiple table, we cannot do one by one. Just like yesterday we have seen 120 table. So if I'm running one by one query for 120 table, that number of query will be big enough. Okay, so always we need a script for automation. And this is my Cloudera. So configuration is required first. I have scripts created inside this file. I'll copy all these files to my Cloudera desktop. This is my Cloudera. Copy and paste. Okay. And we'll move this all file to TMP directory. So let's go to desktop first and sudo mv. We need this ETL file. So you can write all the file name, copy and paste, space, copy, paste, space, copy, paste, same thing. This file also, and parameter.txt. Exns, that's it. We want to move this to user tmp directory, and now check using lslrt. These files are no more present in desktop directory, so it is there inside user tmp. All these are inside user tmp. Now we'll open parameter.txt. Let me increase this. Parameter, we'll open one by one all this is file. So vi parameter, this is a configuration file which is connecting my RDBMS to Cloudera. Okay, or inside Cloudera, then it is accessing with Hive and other components of HDFS. When we open, we see my SQL schema. So this is database name of MySQL. What is the database name here? This is PRWA. I will write PRWA. ETL schema. I'll change this and give a Hive database name. So we'll open one terminal and type sudo hive. You sudo hive. So we'll create one database in Hive. Or we can use any ready-made if there is database present. So databases. Let me create one database. Create FIU database FIU. I'll use the same database here in this configuration file. FIU. The scoop job is not required currently. Hive script. This is the Hive script. We'll open Hive script and we'll see. So the Hive script is there already. Hive script OTL and Hive script. What is the use? We'll wait for that. What is the use? We'll see. MySQL table name. So this is a dim customer and my table name is same. And SQL is case insensitive, so you can use uppercase, lowercase. It will work. No problem. I'm giving uppercase thing. In Hive table, there will be one table created automatically when I run my script, and all the data will store inside this table. Dim customer OTL. OTL short form I have given for one time load. Okay, so whatever information is there, I want to extract it and store in my Hive table. And there is a Hive query for extraction from scoop, and directly it can store that data to Hive. So Hive has facility from scoop. Once this is done, no changes, save this file. Main, we need to run this to a script. This is a one-time script and this is a daily script. This is a one-time script, otl.sh, and this is a daily script. Okay. And how we are triggering this script? So we need to know the scheduler for that. And scheduler, let's say we're using Uzi scheduler or Tivoli workstation scheduler to schedule our jobs and schedule name. Now, what is my flow total? Extract data from upstream source, downstream source to HDFS, and after HDFS, perform these two things. First, perform CDC, changing data capture. It's a part of data modeling stage in ETL. And after changing data capture, we will perform SCD type 2, slowly changing dimension type 2. Both parts we'll see individually. What is the use of this? Okay, CDC and the CD type 2. But make sure this is not a part of Hadoop. This is a part of ETL development. And after SCD type 2, this data we are storing in Hive. Once data is stored in Hive, then we are running query on this Hive data with the help of search engine tools such as Elasticsearch or Solar, SOLR. SOLR, Solar is a part of Cloudera. Elasticsearch is part of Apache. It's a looking project. Okay, so I will use Elasticsearch for indexing purpose. Okay, so we don't know these three things: SCD type 2, CDC, and Elasticsearch. We'll check them separately. What is the use of Elasticsearch? How we are connecting? What is the use of SCD type 2, and same thing for CDC. Now, scheduler we are talking about. So this is scheduler. Okay, schedule name. This will be a schedule name. I'll give a short name, sch underscore name. Then here we have job name, job underscore name. We create this in macros using VB script. Okay, so people who know VB script, virtual basics script, or for this activity there is a change team also. Okay, so sometimes you yourself write all the schedule and job name. Otherwise, they will give you one ready-made Excel. They'll give you one Excel. In Excel, macros is already enabled. You just need to give a schedule name and job name. Then using shortcut key of Control S and Control J, Control S for schedule, Control J for job. One job and scheduler will be created. Then we import that to Tivoli workstation or Uzi. So this will be one Excel file in production or in how in real time we check this. What we're writing inside this Excel, that's important. So job name, then dependency or predecessor. I call dependency. Then what is the script name? Because we have daily, monthly, and weekly, so three script will be there: daily script, monthly script, and weekly script. Then what is the directory of this script? Will write here itself. You want to define your server name, because using this you will connect to your server. And then if you want to put any alert that automatically this job will trigger at 10 a.m. IST, okay, or 10 a.m. BST. So you can put this alert here. Schedule name. Currently, I'm using a scoop extraction. So this is the scheduler name. SQ, SQ stand for scoop. Then big data. If you can use a combination of your project also if you want. Let's say FIU and S01. This naming convention we can give, okay, not necessary that this is fixed. It is fixed with some length that you can give 10 characters, 12 characters, 16 characters. So SQ, I'm giving one convention so that whenever anybody sees the scheduler name, they know this is for scoop scheduler. SQ BD FIU S for scheduler 01. And this scheduler is for scoop, and all the job will be running inside the scheduler of a scoop. So job name, I'll give SQ again. Let me change the color for this. SQ BD big data and J01. J stand for job 01. Suppose there are total. How many jobs we are running? Total we are running 120 tables, right? I'll take a yesterday example. What number of table we have taken? So this is my job number 1. Then there will be job number 2, SQBD J02. Similarly, this goes till BD J120. Right? We have 120 tables. Dependency. In this scoop dependency, we can give a dependency of our RDBMS, RDBMS server. That once data is committed there, then only it will start here. Okay, so dependency means if data is not stored in RDBMS, then this job will never start. This job will only start when this dependency is satisfied. So if you want to give that, we can give. Otherwise, we can keep this null or blank also. Script name. Script name will write the directory. So script name is daily.sh. Suppose this is a daily table. Daily means this is running from Monday to Friday every day and bringing 3.9 GB of data. Script name user user then BD, that's a big data, and there is a one script name as daily.sh. This is running only in week. So this is BD dot slash weekly.sh, and this is monthly.sh. User BD monthly.sh. Server name GVR DSR 006. Whatever server name you have, you can give it here. Server name means your host name or IP address, and these are same. Alert: if you think that this job should start every day at 10 a.m. BST, okay, this time zone is, let's say, in BST. So 10 a.m. BST, we'll fix a time. Before 10 a.m., this job will not start. Say this is 10:05. So likewise, we can put alert if you want. So alert concept is clear. Then after scoop extraction from J01, and I'm currently creating a scheduler, right? Second one will be SQ. One second, I'm getting a call. Just a second. Okay, SQ. So sorry, this is for scoop done already. Now suppose after scoop I'm running some Spark job or MapReduce job. So I'll run a Spark job using a Scala. I'll process this data, do some transformation on this record, and store that data to HDFS again. This will be Spark job, and I'll give a naming convention SP. SP stand for Spark Big Data, PyU, and scheduler 02. Right. This is for scheduler of a Spark, and this job will be SP BD J01. Similarly, SP BD J02, and likewise we have SP BD J120, and then we'll write a script here. It will have a separate script for this job, which are shell script having .sh as extension, because 99% time your server will be Linux based, not a Windows based. 99%, unless you're working with a .NET application. So most of the Hadoop ecosystem, in fact, Hadoop is also compiled with Linux. That's why they support, or all the companies I've seen, they're using the Unix and Windows, Unix and Linux server only for their backend activity. SPVD J01, this will have one script user. Let's say this is BD slash. We'll keep all the script at one place. This is having a Spark underscore process.sh. This is a name, okay? User lib, and yes, dependence is very important here. In fact, very, very important, because we'll again go back to flow. Suppose I'm extracting data from downstream source to HDFS using a scope, right? And if this is fail for some of the table, then if I run a Spark job for this, or obviously it will fail, because without data, what should I process? If data is not extracted in HDFS, your very first requirement is you need data in HDFS. If data itself is not there, then obviously other job will fail. Suppose I'm targeting to process this data, whatever is coming through this first job. If this is fail, then automatically this will fail, because when this will try to read the data, it will say there is no input file available, and it will throw me one exception: input path does not exist if I check the log file, right? This is why we need a strict dependency here. If this job is not succeeded, we don't have output, then this job will never start. And what is the dependency? We give dependency scheduler name dot job name. Okay, scheduler name dot job name. So for this, dependency is scheduler name. I'll write the scheduler name sq bd fiu s01 dot sq bd j01. If this is not done, then this will not start. Otherwise, I will get error and exceptions only if this starts. So that's why this dependency and everywhere. Suppose for job 2, you think I need for this Spark job 2, you want dependency of this also and this also. So you'll have to give this dot this comma this dot this again. If it is having dependency on only this, then you can give this scheduler name dot this job name. So whenever we have any dependency from any job, we'll pass it here. Suppose you have dependency on two job. So scheduler name dot job name comma scheduler name dot job name. We'll write with comma separation. Okay. Then this is the script part. This is the server name, alert time. You know how we can set the alert. After Spark, I'm running SCDC and SCD type 2. So there will be two more scheduler. I'll write all the scheduler. Two more scheduler. CDC BD S01. Then I will have their jobs CDC BD J01. Now dependency again. I'll say if this is not done, then this CDC job will not start. If this Spark processing is not done for this job. So what is the dependency for CDC first? This dot this. Here we'll write dependency SPBD SPBD FIU S02 dot SPBDJ01 SPBDJ01. If you think there is one more dependency required, give comma scheduler name job name. Then script name, it will have a separate script for CDC. CDC script dot sh alert time, and likewise I will have total CDC BD J120 because 120 jobs are there. Then after CDC SCD type 2, slowly changing dimension, SCD T2 BD S01, or you can give 01, 02, 03, 04. As I said, this naming convention we can define. No hard and fast rule that this is only the name. SCD type 2 BD J01. Again, this is going to SCD T2 BD J01. Some dependency if you require. If no dependency required, just leave it blank. Last job will be HV for Hive and BD S01 HV BD J01 HV BD J120. If you check from this to last, how many scheduler we have total? 5 scheduler. Highlight scheduler number 1, 2, 3, 4, and 5. 5 schedulers are there, and all the schedulers are having 120, 120, 120 jobs. So total 5 scheduler into 120, 5 scheduler into 120 jobs is equal to how much? 12 into 5 is 60, 600 total jobs we have for this project to run. Now we will check what is my cluster capacity, how many data it can process at a time. Okay, so obviously this other jobs have a dependency. If this all 120 is not done, then this will not start. If this is not done, then this will not start. If this is not done, this will not start. They have a predecessors defined. But does that mean if I am running this scheduler of a scope, so it will wait for all the 120 and then only it will start? I'll repeat, this is crucial. Does that mean once this all 120 scoop job extraction is completed, then only this will start? Or if this is done, then immediately this will start? That's what is a parallel job. If this is done, then immediately this should start. That's what is a parallel, right? Because if I'm saying if this is 120 is complete done, then only it will start, then it's a sequential business. It's running one by one. So if this is done, this will start. If this is done also, then this will also start, because dependency is only with this job. So in parallel, we have some scenario where suppose my out of 120 table, 32 job is completed. Let's write the number. 32 job is completed for scoop. These are the small running jobs. And all this 32 job which are having dependency for Spark jobs will immediately start as soon as this gets completed. So this 32 job will immediately start. And suppose out of 32 this job, 15 is completed here. 15 job is completed out of 32, because again there are small running jobs. Then this 15 job will start here, because all dependency is satisfied. And out of 15, let's say here 10 is completed. 10 is completed out of 15. So all this 10 will start here. And suppose 7 is completed here. All this 7 will start here also. And suppose 3 is completed. So 3 will give me the final result, that this 3 job has completed from first stage till last stage so far out of 120. Others are running because maybe they are having large number of data, uh, volume is big. As we have seen, we need 263 slave nodes, right? So 263 slave node means now how many number of CPU and total RAM we have. Because if I'm submitting 120 jobs directly here, if I'm submitting 120 jobs, how many number of core is required? CPU and RAM is required. I will take a number. So 120 jobs running in parallel, and it's running in our Hadoop cluster. We have total slave plus master. So this slave is 263 and this master was 4. So total we had 267 size of cluster. That's our cluster size, referring to the yesterday number 267. Then if 120 jobs is running, not all 120 jobs, because these are based on daily, weekly and monthly. We had total 70 jobs for daily, right? So 70 table is running every day. And suppose we'll pick number. So 70 table today, what is the date? 24th July. These 70 jobs are running and they're expected to bring 16 terabyte of data from RDBMS to HDFS. So how many resources I need for this 16 TB data? Calculate how many blocks is there first of all. If 16 TB is the size of data which I'm expecting today using all this script, 16 into 1024 is in GB, and then again 1024 is in MB. I'm converting this in MB. So 1024 first I converted in GB, then again 1024 converted in MB. Basic math. Divide by 128, and this goes 16 into, so 120 divided by this goes, I think, 8 times. Okay, 8 times. You can calculate it also. And 16 into 8 into 1024. See how many blocks. I'm using calculator. 16 into 8 into 1024. This is 131072. 131072 MB. If you convert 16 TB into MB, I'll get this number. And this is the number of blocks. This is the total number of, because I have divided by 120. So this is the total number of blocks which I want to process. So if I want to run a parallel job, I need 131072 CPU available, then only it will work. So if I have total 263 slave, how many CPU can be there? If one slave machine, slave means data node and node manager. If one slave machine or node has 8 core or CPU, okay, and 16 GB RAM, 16 GB RAM. So total 263 will have, then 263 slave will have, below figure, 263 into 8. So I'm calculating first CPU. In fact, total CPU 263 into 8. Calculate this. 263 into 8. 263 into 8 is 2104. So total CPU is available here in this machine is 2104 CPU. And you know from where we can check this? In our actual server. There is a Cloudera manager. So using Cloudera manager, I'll call CDH manager. CDH is a short form of Cloudera. Cloudera manager we can use to check number of total CPU core available, or all the details of our cluster. Second thing, RAM. So total RAM, because if I'm running in Spark, I need to know this is RAM also, so that I can manage my tuning part using executor codes, driver memory, and total memory. So total RAM is 263 into 16. If 8 is this, then 16 will be just double. I'll multiply with 2 more. So 4208 GB of RAM is available. It's in GB only, right? So GB of RAM is available, roughly 4 terabyte, roughly 4 TB RAM, which is good number. Now, if you have 2104, is this a standard that one slave has 8 CPU, or it can vary? Suminda, we can increase, we can decrease and increase this number. So this depends on our which type of hardware we're using. There are two types of hardware: commodity hardware and enterprise hardware. So if you're using enterprise, it's a bit of cost, like SSD, you can take a difference of SSD and HDD. SSD is a solid state drive, it's enterprise hardware, and HDD is a commodity hardware. So if you want to increase the time, you can increase it. The standard one, I'm using the standard one, 8 and 16 GB wiki for slave most of the time. Now 2104 is a CPU, so how many tasks we can run in parallel? I think the answer is in front of you. If 2104 CPU is there, which means I can maximum run this many number of tasks only. 2104. Again, we'll write here. In parallel, 2104 task can be submitted. Task can be submitted to a cluster. Submitted to a cluster. Okay. Then, if 2104 task can be submitted to a cluster, and I'm assuming that this is taking total 35 minutes to be completed. So it takes 2104 task takes 35 minutes. Then I have total 1,31,072, right? Can we divide this by 2104? So if this is taking 35 minutes, then total task, and in this total task we have 131,072 divided by 2104. So this is equal to whatever number is coming, I'll multiply with 35 minutes. 131,072 2104, 62.29. Okay, this is, I'm calculating the total cycle. I'm considering this is as one cycle. So one cycle takes 35 minutes. Then how many cycle I need, right? So divide this by this, we'll get the total cycle. And this cycle is coming as 62 cycle. So one cycle is 35 minutes, then 62 cycle if all is running in parallel and with a good amount of time. 62 cycle will take 62 into 35 minute, which is equal to 62 into 35 is 2170 minute. If I divide this by 60, this is 36 hour. 36 hour in total. Okay, so 36 hour is total time taken by our cluster for handling this many jobs. So here we have talked about total number of jobs and scheduler and their dependency, how the job and scheduler will have dependency for each other. Then once we know the scheduler, we'll start reading this script. First, we'll open otl.sh and check this. So vi etl job custom otl.sh. Shell scripting is a combination of Unix command. Okay, so I feel this is good if you know. Shell scripting we need for automation. If I want to run a script or run a multiple jobs, there is no any other tools defined. So learning tools better than you can learn this Unix thing. You can schedule any number of jobs for any programming, not necessary Hadoop only. You can automate any jobs from any module or any tools. Okay, source, and what we're writing here, ETL job. We'll read from line number first. Source user tmp parameter.txt. So user tmp parameter.txt, this is present in the file. This file is present inside this directory. Source means I'm saying read, whenever I call this a script, read from this location, and I open first this file only and given my database name of MySQL, given database name of Hive, and given some other script also. So two things is main, connecting with RDBMS and writing it to Hive database. This information is available inside parameters.txt. Export ETL schema. This ETL schema is defined inside this file, parameter.txt. Hive script OTL. I'll open this Hive script OTL after understanding this script. Export MySQL schema. This is the database name of RDBMS. Export MySQL table. This is the MySQL table. Export Hive table. This is the Hive table, which is dim customer OTL, right? So Hive table, RDBMS table, RDBMS schema, Hive script. We'll wait for this. Okay, let's this put on hold. We'll check this script later. ETL data schema. Now echo. Echo, why we are using echo? Just for printing purpose, so that we know what our log is reading and where our code is. In program we use print to debug our line, where our compiler is, which line they are compiling. But in Unix we don't use compiler, we use this echo to print where we are. Okay, that gives us one short information. We are in line number 10 or line number 20 or line number 15. We get that detail. Q I have given for understanding purpose, because yesterday we have seen the flow of development, then SIT, then UAT, then OAT, then production, right? So if I'm running some script in dev and I'm moving that script from dev to SIT, this queue will change. Okay, so this is for user information that this script is running on which environment. It's in dev environment or SIT environment or UAT environment. Script time. So in Unix we have a function of date. It will tell me what time this script will start. This script time will read my system date. My system is using some other US time. Okay, different time zone is there. So whatever time of this system is there, it will pick up that date. And plus underscore s, this is a string, so it will say date along with the time also and format it. Then next one, if you read this line, this is a normally scoop job which will pull all the record from the RDBMS table to user Hive warehouse directory as a table. And if you remember, this directory is for what? User Hive warehouse directory is Hive by default directory, and all the table which we create as internal table. There was two table concept, internal and external. So whatever table we create as a part of internal table, always we create that inside user Hive warehouse. By default it goes there only. We don't define the location, which means table data will present in this directory and it will point to Hive. This will automatically create a table in default schema. That's a feature of Hive. Then query line start from, so let me set the number also, set new line number 40. So in 39 I'm starting this jobs, and line number 40 is my script, is my single query. When we started scoop, we were running this query one by one in our terminal. What I'm doing currently, I'm taking that query to my script. So whatever query you need, that you want single import, you want that table import. So we will have to write these queries in our script, in our configuration file, or in this script. Suppose there are 120 jobs, then obviously I will not write in this script. Then what I can do, I can pass that 120 job location to this script. So maybe I can export it just like at top I have exported. I can create a 120 jobs configuration and export in here. Currently I'm taking for one table, that's why I'm writing the query itself. What is the query? Scoop import connect JDBC MySQL. This is a connection URL. From this to this is a connection URL. MySQL, then IP address. And this IP address we will check. When I share this script to you guys, you also check the IP address. I'll go back and check my IP address from this machine. So open a terminal and type here ifconfig. This is the IP address vmnet1 we need for a scoop 6841.1. Close this, go back, I for insert mode, and we will change this. 74 was my previous IP address. So 41.1 IP address of, can't hear me. Anshika, same problem you're facing also? Or Suminda, your network is okay. So here I was talking about IP address. Okay, I've given IP address. Then my SQL schema, MySQL schema. MySQL schema is what? This is my RDBMS database name, which is PRWA. So it's recommended that never hard code it. Okay, I should not hard code this also. Write this information somewhere in my parameter.txt. Okay, because what will happen if you share this script to production box and suppose any changes required there, then you cannot go and change there because you don't have access. That's why we create one configuration file or property file, and we keep all this small details there, like username, password, IP, and we pass this arguments, these parameters, so that if any changes is coming also, we are not changing the whole script, we are opening the configuration file and just doing a small changes. So that's a good practice. Work wise, it will work here also, it will work there also, just a part of good practice. Then username, password. Username is root, MySQL. Username, password is root. Hyphen table. This is the MySQL table, which is dim customer. Dim customer, again defined in parameter.txt file. Hive import. Hive import will import that. This is the argument for import purpose from RDBMS to Hive. Hive table, and this Hive table is dim customer OTL. Dim customer underscore OTL, right? And number of mapper, it will take 1. So I'm giving number of mapper 1. I can give number of mappers multiple also, but we know how this number of mapper thing is driving, how this is working based on the primary key. If PK is there, then we can define the number of mapper. If PK is not there, primary key is not there, then we cannot define number of mappers multiple, it will be 1. And we know in a scoop by default number of mapper is 4 and reducer is 0. So if I do not write this, by default it will take 4. If table has a primary key, it will work. If it doesn't have, then it will fail. So for safer option, since I have not defined any primary key, I'm giving it 1. And we know all the concept of primary key, how they work, and the number of mappers. After this part, scoop in time. Now scoop start time and scoop end time. So here it will take one time, let's say 11, 10, And in a scoop in time, it will take one more time, which is 11, it's a 21. So we will know this one job is taking 11 minutes for completion using one mapper. That the statistics you get using a scoop start time minus end time minus the start time. Once this is done, you are using echo again, echo for printing, and you're printing. It takes this time, start time minus this time, whatever time is there, it will calculate it and say seconds to complete this task in a scoop. So 11 minutes means 11 into 6. This will tell me 660 seconds. This is scoop, whatever time they're taking. I'm taking 11 minutes as a number. Suppose this is just done in 5 minutes, it will tell 12 into 5, 60. Sorry, 5 minutes means 300 seconds. So this will tell me 300 second scoop job has taken. Okay, that is good for your tuning purpose. Suppose you are completing today in 300 seconds, then you said this is more time. Can I complete this in 30 seconds? If you do not know this, then how can you tune it? Right. So first we should know what time they're taking, how much time they're taking, and how can we decrease this. After that, I'm using one script. If job is completed, it will give me one acknowledgement. So this is like a if-else condition. If-else condition of your Unix scripting. In programming in Scala, we have seen if-else condition. If this condition will pass, then this will print, else it will go there. Same thing. If it is giving me equation as this RC I have given question mark, so it will tell me scoop job has been completed successfully. Otherwise, the scoop job has not been successfully completed, and it will print this scoop job is failed. This will store in my log file, and I will get to know that the job is failed. Then echo starting. So once this is done, line number 51, my scoop is over here. Line number 51 is a boundary for a scoop. Then from line number 54, it is starts Hive. And in Hive, they're printing starting Hive jobs. Okay. So I think let's see this Hive jobs on Monday, how this Hive job will start. So from line number 56, again, we will reread this because this will take a bit time and we'll go slowly. We'll understand every bits of it because this is script, and the same script we will be creating in our production also. So from Hive scripting, will continue on Monday.